Venus, the second planet from the Sun, has captivated humanity for centuries. It shines brightly in our night sky, often called the morning star or evening star. This celestial beauty holds a special fascination for astronomers and space enthusiasts alike. Why? Because Venus is often referred to as Earth's twin. Venus and Earth share some striking similarities. They are remarkably close in size and mass. This makes them planetary siblings in the vastness of space. Both planets possess similar compositions, hinting at a shared origin in the early solar system. These similarities, however, are overshadowed by dramatic differences. Venus is a scorching, hostile world shrouded in a thick, toxic atmosphere. This makes it a stark contrast to our own vibrant, life-filled planet. Despite its inhospitable nature, Venus holds valuable clues about the evolution of planets. Studying this enigmatic world allows us to better understand our own. It also raises intriguing questions about the potential for life beyond Earth. Let us embark on a journey to unravel the mysteries of our fiery twin, Venus. The similarities between Venus and Earth are more than just skin deep. They are practically the same size. Venus has a diameter of about 7,521 miles, while Earth measures about 7,926 miles. This difference is less than the width of some countries here on Earth. In terms of mass, Venus tips the scales at 81% of Earth's mass. This means that you would weigh slightly less on Venus due to its slightly weaker gravity. However, the similarities end there. Clouds. These clouds trap heat, leading to a runaway greenhouse effect. This makes Venus the hottest planet in our solar system, even hotter than Mercury, which is closer to the Sun. Venus's atmosphere is a key factor in its extreme environment. It's incredibly dense, composed primarily of carbon dioxide, 96.5%, with a small amount of nitrogen, 3.5%. This is in stark contrast to Earth's atmosphere, which is primarily nitrogen, 78%, and oxygen, 21%. The thick carbon dioxide blanket acts as a trap, preventing heat from escaping into space. This is the greenhouse effect in overdrive. The atmospheric pressure on Venus is also immense. It's 90 times greater than Earth's atmospheric pressure at sea level. To experience this pressure on Earth, you would need to dive more than half a mile beneath the ocean's surface. The thick atmosphere also creates a phenomenon known as superrotation. This means that the atmosphere circles the planet much faster than Venus rotates. Winds in the upper atmosphere can reach speeds of over 220 miles per hour. Venus's clouds are not fluffy and white like those on Earth. They are composed of sulfuric acid droplets. These clouds reflect sunlight back into space, giving Venus its high albedo. This is why Venus appears so bright in our sky. However, these clouds also contribute to the greenhouse effect, trapping even more heat. Beneath the thick, hazy atmosphere lies a landscape as alien as any found in science fiction. Venus's surface is dominated by vast plains covered in volcanic features. These include lava flows, shield volcanoes, and volcanic plains. Scientists believe that Venus is still volcanically active today. However, no active eruptions have been directly observed. Radar images from spacecraft have revealed a world of extremes. Towering mountains, such as Maxwell Montes, which rises to a height of 7 miles, rival Mount Everest in height. Vast impact craters dot the landscape, evidence of a violent past. However, smaller craters are less common due to the thick atmosphere, which burns up smaller meteors before they can reach the surface. Unlike Earth, which has tectonic plates that constantly reshape its surface, Venus appears to have a static crust. This means that volcanic features persist for much longer periods, giving us a glimpse into the planet's ancient geological history. The surface is also incredibly dry, with no liquid water present due to the extreme temperatures. Venus has a peculiar rotation that sets it apart from most other planets in our solar system. It rotates on its axis very slowly, and it does so in the opposite direction to Earth. This means that on Venus, the sun rises in the west and sets in the east. A single day on Venus is equivalent to 243 Earth days, longer than its orbital period around the sun, which takes 225 Earth days. The reason for Venus's retrograde rotation is still a mystery. Some scientists speculate that it may have been caused by a giant impact early in the planet's history. Others believe that it may be the result of gravitational interactions with the Sun and other planets over billions of years. This unusual rotation has several effects on Venus's climate and atmospheric circulation. For example, it contributes to the planet's extreme temperatures and the superrotation of its atmosphere. It also means that a day on Venus is longer than its year. Despite its harsh environment, Venus has been a prime target for space exploration. The Soviet Union's Venera program, active from the 1960s to the 1980s, achieved several milestones. These included the first successful landing on another planet with Venera 7 in 1970. The program also captured the first images from the surface of another planet with Venera 9 and 10 in 1975. NASA's Magellan mission in the 1990s used patterns and volcanic activity. Future missions such as NASA's Veritas and Da Vinci Plus missions are planned for the coming decade. These missions will provide even more detailed observations of Venus's surface, atmosphere and interior, further unraveling its mysteries. While Venus is currently a scorching desert, some scientists believe it may have once harbored vast oceans of liquid water. Early in its history, when the sun was fainter, Venus may have had a more temperate climate. This could have allowed liquid water to exist on its surface. Computer models suggest that Venus could have maintained liquid water for billions of years. However, as the sun grew brighter, the planet's surface temperature increased. This triggered a runaway greenhouse effect, causing any oceans to evaporate into the atmosphere. The water vapor would have eventually been lost to space due to the solar wind, leaving behind the dry, hostile environment we see today. Evidence for a watery past remains circumstantial. However, the possibility that Venus once had oceans has profound implications for the search for life beyond Earth. It suggests that even planets that are currently uninhabitable may have once been suitable for life. Studying Venus is not just about understanding a neighboring planet, it also provides valuable insights into our own planet's climate and evolution. Venus is often seen as a cautionary tale of what can happen when the greenhouse effect runs amok. While Earth is not in danger of becoming like Venus anytime soon, the extreme conditions on our twin planet highlight the importance of maintaining a balanced climate. By studying the processes that led to Venus's runaway greenhouse effect, scientists can gain a better understanding of how Earth's climate system works. This knowledge is crucial for developing strategies to mitigate climate change and ensure a sustainable future for our planet. Venus also provides a unique opportunity to study a planet with a similar size and composition to Earth, but with a vastly different evolutionary path. By comparing the two planets, scientists can learn more about the factors that influence planetary habitability and the evolution of life. Venus, despite centuries of observation and decades of robotic exploration, remains an enigma. Its thick atmosphere obscures its surface, making it difficult to study from Earth. Many questions about Venus's past and present remain unanswered. Future missions such as NASA's Veritas and Da Vinci Plus missions promise to revolutionize our understanding of Venus. Veritas will use advanced radar to create high-resolution maps of the planet's surface, revealing its geological history in unprecedented detail. Da Vinci Plus will send a probe through Venus's atmosphere, analyzing its composition and studying the planet's surface up close. These missions will help us answer some of the most pressing questions about Venus. Did Venus ever have oceans? Is it still volcanically active today? What secrets lie hidden beneath its thick atmosphere? The answers to these questions will not only deepen our understanding of Venus, but also shed light on the evolution of terrestrial planets and the search for life beyond Earth. Venus, the fiery twin of Earth, continues to beckon us to explore its mysteries and unravel its secrets.